All right, so I'm going to use this next example as a jumping off point to talk about symmetry and reference angles. So example 5 just is asking us to find the coordinates of point Q on the unit circle. All right, we're given an angle of 130 degrees. now, now it looks like, you're going over by n units and up by n units, so you might think, well, maybe the point is n comma m, right? But given the fact that we have 130 degrees and the fact that we have a calculator. Now, traditionally, back in the old days, they used tables to calculate sine and cosine of a function. But we have a calculator that can calculate the sine and cosine of any angle, and so we know now that the x and y coordinate of that point Q are just going to be the cosine and the sine of 130 degrees. So if I calculate the cosine of 130 degrees. 130 degrees. Put that in my calculator in degree mode. I will get approximately it's negative 0.643. All right. So, and I can also put in the 100, we can put in calculate the sine of 130 degrees. Put that in my calculator and I get 0.766. Okay, so I know now that, if those are the sine and cosine values, then those are the coordinates of point Q, minus 0.643, comma 0.766. All right, so one thing to make sure, though, is that you, when you're working with angles and doing sine and cosine, watch the mode of your calculator. You can calculate sine and cosine in either degree mode or radian mode. And it's easy to switch, and you will need to switch in this class back and forth between degree mode and radian mode. But whenever you're doing these calculations, you better just check and make sure that you've got your calculator in the mode that you want it to be in. All right, so in this case, we want our calculator to be in degree mode and not radian mode. All right, so like I said, I'm going to use this as a jumping off point to talk about reference angles. So let's take a look at this, this first circle here. Now, you can see there's we have this point P, which is at 50 degrees, and then we have the point Q, which we're just dealing with at 130 degrees. Now, I want you to notice also this triangle that's formed, right? If I go over in the x direction, x units, right? That x distance is my cosine value, right? And I go up by y units, that y value is my sine. So you can see this triangle here. The length of the legs, the right triangle for one thing, and the length of the legs are x and y. X being the cosine of 50 degrees and y being the sine of 50 degrees. Okay, so let's look at 130 degrees. Now, 130 degrees is 50 degrees shy of 180. All right, so you can see again this triangle that's formed is a congruent triangle, right, to the triangle that we had at 50 degrees, right? It's a congruent triangle. It's just a mirror image of it, right? It's just flipped across the y-axis. And you can see that the cosine value will be this negative x distance, and the sine value will be this y distance. All right. So what's interesting is that the coordinates of this point Q, which is at 130 degrees, will be almost identical as far as magnitude goes as this point P. This point here is going to be, but it's just that this is in the second quadrant now, so the x is negative. So the value of the coordinates at Q are going to be negative cosine of 50 degrees, and the y coordinate is just going to be exactly the same, sine of 50 degrees. Okay. So 130 degrees, the cosine is the negative of the 50-degree angle, okay? And the sine is exactly the same as the sine of the 50-degree angle. All right, so this 50-degree angle is called the reference angle. So really all we have to know is the sine and cosine in the first quadrant, and then we can figure out the sine and cosines in all the other quadrants, because we can find similar, or we can find congruent triangles in those other quadrants. Okay, so since this is, if I put this in my calculator, I get 0.643 and 0.766 for the sine and cosine, right? Then the cosine here is, which is down here, of 130 degrees is just going to be minus 0.643, and the sine is going to be the same as the sine of 50 degrees. So 0.766, okay? Which is equal to, like I just said, it's the negative of the cosine at 50 degrees, and that's exactly the same as the sine of 50 degrees. The y coordinate is the same. The sine value is the same as at 50 degrees. All right. Okay, so that's the idea of reference angles. So again, if you know the sine and cosine in the first quadrant, you can find the sine and cosine in the other quadrants just by changing the signs, the negative, positive, negative. So for example, here in this next example, now we have a point in the third quadrant, right? In the third quadrant, both x and y are negative, but you can see that this triangle right here, is exactly the same. You know, it's a congruent triangle to the one in the first quadrant. So now we're going over by negative x and down by negative y. So this point down here at 230 degrees, which is 50 degrees more than 180, all right, is going to have the same sine and cosine values. The magnitudes will be the same. We just have to make them both negative in this case. So the cosine of 230 degrees is the negative cosine of 50 degrees, and the sine of 230 degrees is the negative sine of 50 degrees. Okay, so if we put in those values, we'll get negative 0.643 and 0.67 or 766. Sorry, both be negative. They're both going to be negative because we're in the third quadrant where both the x and y values are negative. All right. So we can just keep working around the circle. Here we have another angle at 310 degrees. 310 is 50 degrees shy of 360 degrees. Okay, so you can see again we have this this triangle, right? That's congruent to the one in the first quadrant. It's just that now the y value is negative and the x value is exactly the same, right? So the cosine of 310 degrees, it has the same x value. So it has the same cosine as the 50-degree angle in the first quadrant, right? It has the same cosine value as 50 degrees, but now it's going to have the negative of the y value, which is the sine value of 50 degrees. Okay, because we're now in the fourth quadrant where x is positive and y is negative, right? But the magnitudes of these values are going to be the same. So we're going to have the point 0.643, positive 0.643, and the y value is going to be negative 0.766. Okay? So the point is that if we know values in the first quadrant, we can find the corresponding values in the other quadrants given the reference angle. Okay? So 50 degrees in this case is called the reference angle. For each of these angles, 130, 230, and 310. And then we can use the reference angle to find the sine and cosine in quadrants other than the first quadrant. The sine is determined by which quadrant it's in. All right. Well, that's probably enough for this video. I'll meet you for the next I guess the next one isn't really an example, but we're going to talk about the coordinates of a point for a circle other than a unit circle. So if the radius is some r value, something other than 1.